Now we're going to learn how to solve a right triangle. When something asks you to solve a triangle, what that means is that you're going to find all the sides and all the angles in the triangle, not just the one that they ask you for that's labeled with a variable. So what I did is I went through with these three triangles and I wrote the things that were missing. So ideally, we can use some shortcuts to make things easier, but if you want and you're really comfortable with trig, you can just use trig 3 times to find the missing pieces, but I'll share with you a couple shortcuts. So in the first one, when we have three sides of a triangle, two sides of the triangle, you can find the third side by using the Pythagorean theorem, which was a squared plus b squared equals c squared. So the two sides I have are legs, so that means I can do 12 squared plus 17 squared equals c squared. 12 squared is 144. 17 squared is 289. Then we're going to add those together, which is 433. And then we're going to do the square root of both sides. Which is 20.8, approximately. So we found our first side. Now, if all I know in a right triangle is the right angle, then I'm going to need to use trig to find one of the angles. So I wrote P first, so we're going to label P. And now since I want to use trig, my first step is to label H, O, A from angle P. Now if I had started with angle N, my O and A would be switching sides. So I have numbers at O and A, which means I'm going to use tangent. So tangent of angle P equals O over A. I don't know what my angle is, so tangent P equals O is 17 over A is 12. So I'm going to do inverse tangent of 17 over 12 will give me angle P. Make sure that your calculator is in degrees, inverse tangent, and remember we don't need to get the decimal for 17 over 12, just type that in. And as I say to remind yourself you're in degrees, I'm in radians, so 54.8 degrees. I don't think I left enough space right here. There we go. That's a degree, not a 6. Okay, so now let's talk about if I know two angles in a triangle. If you know two angles in a triangle, what's our shortcut? Well, we know that the angles in a triangle add to 180. So I can do 90 degrees plus 54.8 and subtract that from 180. So 90 plus 54.8 plus angle N equals 180. So we add and subtract from 180. And when you do a lot of these problems, what you're going to notice is that we're dealing with right triangles. So I'm always going to have that 90-degree angle. And so I could actually be always subtracting the acute angle I have from 90 degrees because the other 90 degrees is always accounted for. Okay, so I got 144.8 and then I subtracted that from 180 and I get 35.2 degrees. And we have solved our first triangle. All right, 35.2 degrees. Sorry, my degree symbols are just the ugliest thing ever. I think you'll forgive me. All right, so what's different with the next one is that I have an angle and a side. But I'm actually going to start with the angle here because I already have two angles in the triangle. So I have 90 plus 50 plus angle V equals 180. And when I add those, I get 140, and 180 minus 140 gives me 40 degrees. So there's my angle, and now I need to find the two sides. So MD, the angle that, I always go back with the angle I start with, even if I found the other angle is 40 degrees, so I'm going to label HOA. And for MD, I'm caring about O, so I want O, and the other place I have a number is at A. So O and A is tangent. So tangent of my angle equals O over A, and then I substitute in tangent of 50 degrees equals O is what I want to solve for, over my A is 21. So I'm going to look up what is tangent of 50 degrees, which is 1.192 equals O over 21. And then I'm going to multiply 1.192 by 21. And that gives me right at 25. So MD equals 25. Now here, you could use Pythagorean theorem, or you could use trig. I'm just going to use trig, because I think a lot of us really like trig. So if I'm doing that, I have A, and I want VD, so I want H. So A and H is cosine. So cosine of my angle equals A over H. Cosine of 50 equals 21 over H. Cosine of 50 is 0.643. Since I have the variable in the denominator, I'm going to cross multiply. 0.643 H equals 21. So I'm going to do 21 divided by 0.643. And I get 32. My hypotenuse is 32.7. And if I had done a squared plus b squared equals c squared, I should have gotten exactly the same answer. So I'll just set that one up for you. It should have been 21 squared plus, we found MD is 25, so 25 squared equals my h squared. So you could have also solved that. And let's look at our last one. So same thing, it's easy on this one to find the angle. So we could do 70 plus 90 plus angle U equals 180. And when I solve that, I get that angle U is equal to 20 degrees. Alright, once again, I'm going to do trig with everything. So first thing when we're doing trig is label your HOA, H-O-A. And I'm starting with TS, so I'm going to do A, and I have a number at H, so A and H is going to be cosine. Cosine theta equals A over H. So cosine of 70 degrees equals A is what I don't know, over H is 15. Look up cosine 70 in your calculator. We get 0.342 equals A over 15. And then we're going to multiply by 15 on both sides. 0.342 times 15. 5.1. And that was side TS. And now I'm going to do the same thing for VT, so that I still have H, and now I want to solve for O. O and H is sine, so sine theta equals O over H. And once again, you could do Pythagorean theorem if you want. Sine of 70 degrees equals O is what I need, over 15. So sine of 70, is 0.94 once we round. 0 over 15. Multiply by 15 on both sides. So we should get almost 14. Let's see how close I was. 0.94. So 14. Ha, perfect. 14.1. So to solve a triangle, you find all the sides and angles.